Welcome to everyone who works with PowerMTA and wants to improve the effectiveness of your emails. It's no secret that when working with one, there is no problem with the server. Open a web interface and work with it. But if you have a dozen servers, you constantly jump between them. Open web monitors, you have a dozen open web monitors. Sessions if you need to collect logs or somehow consolidate to data. That's exactly the asterisk problem. I came up with a dashboard PowerMTA system that collects two. With a large number of web monitors in PowerMTA, the data combines. They are in one web interface, in a fairly clear, simple way, and an effective tool. I'm going to show you. In the installation, you get into the script, which after the login shows the following picture. This is the main control window itself. Lists of added servers with ILD. Open web monitors, the panel after download pulls up data from these servers and put them in a table. Data that is directly requested. The server has data that is counted on the panel. The data that is being requested from the server is obviously, as well as in the web monitor, are presented in the same numbers. Here a little math is considered. This relation, the number sent to the incoming. We can indirectly judge the effectiveness of the newsletter. For example, a server with a ratio of not sent to sent. 85% is an inefficient server, i.e. 117,000 sent. 800% loaded. That's nonsense, of course. There is also an active server that, in relative units of only 36%, not sent. They do. That's a pretty good result. The panel has a color gradation that allows quickly determine the effectiveness visually. Server work. Date. The data can be changed slightly when added, explicitly indicating the characteristics of the car. Servers that distinguish one from the other. For example, we can add when adding servers, cluster, and comments. In a cluster, we can specify, for example, a block that laps for hosting, and in the comments, for example, some of our tests stand. Thus, we can distinguish between conditionally added servers. After adding, the status of servers is assigned online or offline, and this status is periodically checked because when an auto-update is enabled, server data is re-requested. It's stored in a database. The main task is just in this console of this dashboard. See preservation of the data received and in the presentation. Visually display these data in a more comprehensible manner. I will tell you a little bit about the schedules that are being built. Based on the data obtained, the panel is designed for two types of data acquisition. The first is when the panel itself requests data, letters, or when an agent is rolling out on our server, it collects data and sends it to the panel, letter S. In the process of working, we can, for example, from the servers to the agent will collect data and send it to us. There is a special field that allows change the cluster, change the comment, and change the format of receipt. Data, agents, but this is probably the story of the future. This makes it much easier to work with servers. You don't need to actually manage the MI. These servers will be agents. You send a command to an agent, and the agent does the job. The action on the server. You don't keep web monitors open, you don't. Active SSR sessions, all done by agents. Next, we see that we have a list of URLs on this. Early, we open the server, fall into it and see monitor that actually copies the interface of the main web monitor, PowerMTA, but with my extra chips there. Here's what. For example, we have a new data gradation, a new display scale. The metric that we see here is the same data, but there is visual vertical line to the left of which are considered data per unit of time. A very good thing, for example, when pointing at a certain n, we see that some data is changing. In the interval of 1 minute, 5 minutes, 15 minutes, everything to the left of this vertical line is counted. We will update the page now. The data is re-requested. The server of this one here, it's located quite well. This means that data is not requested very quickly. While the request is underway, let me tell you that the web interface is below. LM provides additional data in addition to traffic and DE. In addition to connectors, it gives the data about the license, about the download. Data on the characteristics on which the car is empty, the number of resolves, the queue data, about the spool, how much is currently in the spool, the files, the performance data, about DOMs, about connectives, well, if they exist, of course. Most of the time there is empty data, and the bottom part is duplicated, an element that is in the main interface of PowerMTA. So, back to the schedule, besides what we can do. Disable the data source, or incoming, display, or just outgoing we can do, choose. A certain interval, tracking, behind which this interface will be peaked. Observe the allocated interval between 3 minutes. In this interval, there were 685, and now entering 260, graph floating, and they swimming with each other, almost repeating. 1-to-1 interface of the original web monitor, except N. I don't have it in the original. I have it. See that the reason for transitions to backs, block tab. Domains will upload exactly the same data as the file, the original MT web monitor interface, and the same thing on the tab block we have additional. A button that allows, i.e. data loaded. Exactly the same as in the original web interface. New tab to download under the condition allows you to pump out a lot of files you need if you are interested by name, by date, by interval, by volume, for example, by name. File, download only account files. These are files under certain conditions, or for example, we want to. For example, in order for us to swing only VCC files, we choose file name, put an asterisk that indicates everything. Possible additional symbols, and IT. Shows, uploads, all the files he download. We press the download button, and it downloads, either on a dashboard server or on a PC administrator. All selected files, for example, the same. A, the date or date of any given date. Well, for example, there, 14 to 17, and he'll pick up all the files. If you are satisfied with this condition, I will not rock. Then I'll show you how it works. Okay, lock and Alice a little bit. Later, the interface comment, if the standard is open. Comment interface. It shows us all the possibilities. When you add a new chip, you probably enter it. A team that will copy you periodically. The command that you periodically enter on different web monitors. To make things easier, there is a button. which allows for the introduction or fast teams or enter a command yourself. Save it as a source, so let's take something. There, when and we can use that team quickly. These fast teams make it easy enough. You will not need to enter them manually or copy from somewhere. These commands are saved. In the database, you can then be open to everyone, and web monitors or all open servers. Use the command if you need it, and accordingly, use the standard command if you want to. Just the result immediately, the configuration block again. It is almost a standard web monitor, but has its own. User guides, for example, can be accessed immediately. Switch between config and user guide without additional. The slates specifically here are quite convenient. There is an analysis tab that shows how much. The directives used are, well, you can quickly look. Until the function is completed after a while, I think I'll finish it. If we want to change some data in the config. Changed. Click Save. The file is saved successfully. Configuration means rebooted. In the history block, we have changeable data, that is, the history will be saved. The changes that have taken place, and we can observe them. There have been several attempts to change, and to see what has been changed. The heaters load. There are certain patterns if we want something. Change or save, we can also take select. A certain block, press the heat, save, like a template, and then import it somewhere. Backups in the process of saving and editing files. We may have a story when we've got a config. Or we want to pull something back so we can. We can make a backup. After a while, we can restore it. We have a list of backups, time, and accordingly, we can press the recovery button. This backup, it will be restored. The configuration will be rebuilt and applied. We can also use other files that move. We have them if we need to edit them. Block analytics in the process, more precisely in the process. Download this page. Check what is now in this. At the moment of active VMTA, and in a bundle of VMTA domain, we can get the system set up, specifically this server. It looks as follows in the table presented. The names of the directives, their default values, and then a number of the necessary, or more precisely, checkered, which, in this, the moment the results of the check link, domain, and queue also. We can, for example, introduce this option too. Determine if we have a download for this. Queues. Well, are there any changes in the setting? There is, for example, unlimited. Okay, no, it's a default line. There's nothing particularly interesting here. No, but in some cases it shows you something. Specific domains for specific queues, which show settings pink, or rather dusty pink. The color of the data is different from the defaults. They are presented here. So, loaded in the same window, all local. Add the scripts that this server has when clicking. For the record, a request is made for several services, which allow you to check this server by domain name. For example, server, service, or rather, the first. Check IP. There may be other DNS settings. Service, EP. EPI shows settings, not settings. Show. The data from the who is and so on are. Data collected in the system showed in, for example, can. You will need to know the open ports on this server. For what? Well, who knows? The URL scan also provides information about the lists or references that they were detected from this server and then somehow processed. So far, that's all. Lock analyst. That's one of the key functions. What is applied in this block? What is it in the process? Our work occurs most often occurs. It's a story where we need to figure out how we work. What? Our newsletters are moving. Of course we can watch it. Profit, but the technical information is not gone. And dry numbers in CSV files. They most often do not display. The information we would like to see is of interest to us. For example, aggregate data and so on. Here's a visual. Data that may be available to the server. There is a masonry of lock analysts. It is represented in the three clutches, so we can download the CSV file from PC. Administrator, we can view the downloaded files. It is in the storage of our server. Our dashboard, or it is data from the PMTA server. Click on Receive all files, request all files, logs, and we can download this data. Download, click. Download and analyze directly or collect data by unique senders until we need it. We don't need it yet. There's a nuance. There's servers who receive data from which our services, not called three-letter blocks and downloads, only a certain amount and then the session. It breaks. I've done a round trip, but here's one. Specifically on this server, how it works is loaded. The file is large, but it is downloaded. Only 32, 40, or 48 kilobytes. Well, from 12 to 48 kilobytes download. After that, the session breaks up. This problem means all the main switches, more specifically the services that the connection is broken, considering it an active WPN. I told you about these servers, so after downloading, there are actually not many servers like this. Mainly bourgeois servers that to only certain hostings after downloading data. We can view the file in the action block S. This is a list of already sorted things like this. In the form of a familiar file, we can download it. The whole thing, if we have it, well, it's all downloaded here, so we can download it. It's in view. How? It's 100 lines, or if you're interested, we can view the data in format, that is, in format, in which he himself comes to us this way. The server just shows you in the form of a demonstration. Take some other server, like this one. Domain usually does not have any problems here. By the way, even began to make some mailings quite themselves. Not bad. We're going to look at it now. So let's take it as. Explore. Take. Open the tab from the Power Server. NK. Check the server. Check all the files that. We're going to make a download like these. Sleep balls, on which we have on X2, 560. So interesting on X8. Well, Here we go. Upload several files. Download selected files. Start loading. After loading, we will be transferred. In the Storage tab, we have files in this tab. Each file is stored in its own, all files related to a specific server stored in a specific directory. Well, you can also see us here. It's not very interesting now. We've already looked. We've chosen all the files, and let's analyze the selected one. The amount of time the analyzer processes these files. It happens several times, dozens of times. Provide aggregated information, which the number of records, the number of deliveries, balances, what percentage is processed, number of files, delivery time, average, not maximum, shows. The number of queues, what exactly were these queues? Average queue time, how many letters? In general, this queue shows LMT statistics. It shows the IPishnik's executors, who was the administrator, showed the average volume of emails sent is 40 kilobytes. SNS shows expansion at connectives shows. What was the number of bases? There is an interesting. I'll talk about it a little later, statuses. And the return codes, and most of all, probably interesting. Time interval, this one here, in the process, and we can see it in the form of a diagram like this. When we had the minimum number of shipments, when the maximum number of shipments, or rather deliveries, if we had any errors, they are presented in the form of a pie chart. Here we can include it. Turn them off if you are interested, and there is a summary of statistics on the number of top domains and their characteristics. How much was sent to this domain? How much there were rebounds, for example, on Yandex in this case. This person is quite good sending. You, Penfish. 1878 delivered just 19 rebounds. Percentage. 1 bounce. But at the same time in Jim he has a complete underdelivery. And then there's a little bit of math. And again it's called Hells. Is considered a problem domain, is shown here and detailed. This was the first analysis that was. And then I rethinked the structure a little bit. I made an alternative report. Open it. Move on. In an alternative report, we see the same, the graph itself, but the data is slightly. In another form, there is detail by type of errors. There is detail. On the top of the queues, a complete list of all server responses. More precisely their types and the number of summed up. For example, the total number of deliveries was 2,448. Non-delivery, also summed up by number of senders. We had one the recipient's addresses were, the domains that participated. In the process, well, domain recipients, respectively, groups of codes are combined into a block. We can also see group, reference, general database, problem domains. If we have any data on TLS, they will be displayed. The time of delivery, designation, proxies. That's all. If there's this data in the logs, in these logs, there are no specific data logs, so they are not used. Well, and accordingly, empty data on health, then activity, which was on graylisting, on trolling. By the way, there's no trolling data. There's no trolling data. No, there's probably no graylisting data either, General. Health is considered as 90. In this case, it is quite possible for domains that do not work well. Water statistics are presented in the form additional data opened by the button, such as there's also a cluster breakdown, and it's here. If you send not one domain, but a group cluster, they are also very interesting, and there is a block of recommendations. Maybe it will be applicable a little later. It will be updated. Well, this is the summary statistics. This is a good example of the mailing process, and some can be done. Interesting findings if the data doesn't suit us. So if we want to update the report, we can upload it. Server, or reload the data if you want it. Save it in JSON or HTML, and then reopen it. Something else if we're not interested in data right now. We can clean them up, so that's what the reports are. There is a button to collect data on recipients. This button actually shows us that data, which we can process from Dashboard Storage Select. Active files that we have, select all statuses. Let all the statuses, then choose the interval. We won't put any filter in a week. Let's start. Parsing with these files in this date interval. 1048 unique soaps were processed and discarded. What it is for, the button to quickly receiving the recipients for whom the VAT nailing, if we want to unify somehow. For example, let it be Yandex, so in the meantime, we will do it. It shows us all the different domains. Soaps for which the parser collected. We can select and copy only selected ones. Copy everything, copy everything, copy everything. All of them. There are only 201, so we can do that. It will be downloaded, and it will be downloaded as a file. But we will take Yandex RU, process it, and we have it out. In 1098, unique soaps opened, and he downloaded us all. Yandex and I, RU, Bell. That's a parser. It's very fast. It's a fast tool. It's pretty good at collecting data. We can collect it from already downloaded files. Or we can collect it from the PowerMTA server itself. As for the server, we will return the main console. The console does not only work with one server, but with many. It works pretty well, and there are a few cool settings, for example, setting up graphics. I'll come back here. Some data being sent, some data being sent to. We need to present the data as interesting values. There are graphs. Go to them. The page is actually it processes all the data recorded in our database, the source of this server. Select any server, the first to be found on a timestamp, on a scale. X and Y, for example, take a message. Let's take the 17th. Let's take the 16th. We will try to make a schedule if, or there's a lot of data. He'll build enough. The sample will be taken for a long time and then built. There will be a schedule, data that is built enough. Interesting, because in a way other than collecting data there every 5, 10, 15, 20 seconds and accumulate them. In the database, there is no other option that is here, well, from time to time. The number of outgoings built here is presented. Here's a graph, and there's a detailed graph in the process. Analysis. We can see that this server sent these domains, and these domains have some errors. In the process, they encountered some loss. Delivery problems. All these data are separated, and they are clustered by type, and these types can be filter in this case, so, well, not much here. Well, interestingly, there's only one. Yeah, just one type of error, not a very interesting server. Any other server has no errors at all. No, 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 no. Sending, but no errors were recorded. No, no, there are other types here. Timeout types respectively, timeout errors there are. The DNS types, so here we can sort them out. If there is no spam, there is no accessory, but replibit, connectlibit. And DASO, well enough, but not very much either. There are servers that are facing all kinds of mistakes we have if we are interested. More detailed information, we can see that in the selected interval, 14 domains were registered, with 27,540 errors. That's a lot. And look at it in the interval, that is, there will be some clustered information divided by time. And so we can see that, for example, we have 0. From 0 hours to 1 hour, there were only 0.8% errors. It's a little bit of a problem, or maybe it's a problem. It would have been, for example, if we had a big percentage of errors in a particular area. The interval, we can look at these intervals. Transformation of our newsletters, thus analyzing trends, or we may export them to the file if all of this is interesting. So let's go down a bit. Information. On the uploaded data, you can look at the error that there were a lot of servers here. And you can collect a variety of samples, for example. You can make a sample, any sample at all. Interesting, for example. The number of entries, I don't know. Percentage of filling, no. Percentage of filling, it is not interesting, but only in a spool, so this metric. He can't build it, and he didn't talk about it. And converging maximums data, when a lot, it is enough. It's a long time thinking. Well, it's not very revealing here either, because the data hasn't been changed. Okay, let's not. Torment the system, then you can play. Data. There is a lot to do with scheduling, probably. We are interested in working with databases. Since all data is written in the database, there is a page that shows, first, a list of all downloads. Well, all the databases used have some keys. More specifically, the buttons with which we can make management, now loaded, statistics are updated. Well, let it be updated. Apparently there is a process there, which does not allow normal loading of data. What we have will start from the bottom. If, at some point, the amount of data already available, we can drop all the data completely or optimize it. Database through a vacuum, if we have long enough. The system works. We can clear binary file, database, or clear agent buffer, about buffer. Agent, I'll tell you a little bit later, there's enough data. A large number, and if we have active, on average, 50 servers can be sent per day, accumulate up to a gigabyte of logs, or maybe more. In order not to overflow the hard drive, there is a button. By cleaning up the old data, we can select the interval, time. For example, set 10 and press the clean button, all data. After 10 days, we will be deleted from our database. So the list of tables we can also optimize. If the data has been deleted or the data is outdated, there is a tab, SQL. The idea was to in one tool, you can fully assemble the tools that do. This is because the database contains a variety of data. We want to get them, or somehow get them out. HTML page, we have a graph, database, structures. Well, you can look at our database and see what it is. Data. What types? There is a window of the requester and below results. Quick commands are introduced. For example, we want to statistics on server statuses and click on. We get a result. We can get that result. Copy to the bead or save to the file, we can. Take advantage of something else, like online. What servers we have? Offline. Here we have. There's some data extracted from the table. Here's the data. Again, we can copy or save analytics. There are also a number of requests. We can. Let us see them, and see them. It is necessary if we are interested in certain the requests we will make from time to time are button your request. We enter the request. Click on your request. Request save. Give him a name. Save. And then we save it to the database. We can make these requests quickly. It can be a lot if you want something. Quick data to do. Then quick requests extract from here. Convenient enough not to write manually. So, with databases there, with graphs there, domains. This is a tab that is focused on the future, meaning it is about adding a certain number of domains. In our system, background checkers will be analyzed. These domains have different DNS characteristics, and this data will be consolidated and released again. In the general console, I've entered several domains, analyzed. These are the statistics that can be found. And look at each domain data, for example. The domain fb.com is in some kind of blacklist, in the reputation of ugly. It's a sort of scoring 65 out of 100. There's data extracted from it. Quiz. There is data from DNS, textual, some data. The blacklist he's on, so come back. Up. Slightly more advanced data in the DNS block. They're here. Mail service, Epichniki, infrastructure. If we're interested, .soldns records, IDTR, text records. All this is done in Checker fairly quickly. Statistics. If we have any requests, here we are. We make requests several times and we will have data here. And that's the essence of the whole story. We can. Domains are linked to specific servers. So we have domain. We choose a specific server. For example, one of these, and we do the binding, and this one. The server is attached to this server, is attached to it. This particular domain, made for this is the future when we are going to work together. Our domains, so I'll show you now. We're coming back. The main thing is that the script will be implemented in these scenarios for different events will be transmitted in config. PMTAs are these domains. They will be relinked, and PowerMTA will be restarting with these new domains. The point is that we link to certain servers, domains that will be used by these servers. Okay, very interesting feature, so let's turn it off. This is the notification. We will turn off the alert for now. But, duh. Alright, let it stay on, reports that this is. So, we can by group of servers, by all, by selected servers. Here they are loaded on the cluster. For example, in this or that way, or in any other way, or in any other way, or on the date of the addition, but the date will do. For our servers, within a time interval of 5 minutes, make a vaccination and obtain consolidated data, aggregated data. For all servers, so as long as we select the servers, we'll do it. So, the data is being loaded here in care. In what format? All data is processed by quantity. Queues, the number of bulls, in fact, here they are. By the number of these queues in pause, mode, and by the total live. Number of queues, all data shot.